Hey everyone, welcome to our podcast. Today we'll be chatting about meta-analysis.
Oh yeah, so applicable. All the majors.
And for faithful listeners, you know I'm Sally.
And I'm Kelsey.
But for the rest of y'all, my name is Sally Evans and I'm a Def Ed major.
And I'm Kelsey Holton and I'm also a Def Ed major. All right, let's get into it.
You know, a lot of people use meta-analysis, but they don't even know how it came about.
Yeah, let's start from the beginning.
Well, in 1952, this dude, Hans Isaacs, reviewed the available literature and concluded that there were no favorable effects of psychotherapy.
That's like talk therapy, right?
Yeah. So after 20 years of research, the field still didn't come to a consensus on psychotherapy.
So what'd they do?
Well, this guy, Gene Blass, did something in 1978, the first meta-analysis.
And?
It works. Got anything you need to talk about?
All right, so the purpose of meta-analysis is to answer a defined research question by collecting and summarizing all empirical evidence that fits some pre-specified eligibility criteria and develop a single conclusion that has greater statistical power than any single study. This is stronger than any single study due to the increased number of subjects.
A meta-analysis is a quantitative statistical analysis of several separate but similar experiments or studies in order to test the pooled data for statistical significance and effect size. The basic question being asked in a meta-analysis is, does what we're doing make a difference to X, even if X has been measured using different instruments across a range of different people?
This statistic is used for empirical, not theoretical information. It produces quantitative results rather than qualitative findings. Even though qualitative studies can appear similar to the untrained researcher eye, those kinds of data cannot be compared across studies. We want to find those effect sizes that have comparability.
So this statistics wants to examine relationships that are comparable, like effect sizes or correlation coefficients, apples to apples. This comparison is embedded in the meta-analysis question itself. The findings can approximate, or estimate an effect size for all the studies.
The effect size makes the meta-analysis possible. That's our dependent variable. It standardizes findings across studies so that they can be compared. There are different ways to measure an effect size, like standardized mean difference, correlation coefficient, odds ratio. Stay tuned for part 2 of this podcast when we explain those at length. The independent variables are the studies involved in the meta-analysis. There's no limit.
So there are several things we need to think about when we're setting up this research topic for the meta-analysis. There should be quite a bit of available literature, and hey, you qual folks, this has got to be quantifiable. The hypothesis should not require the analysis of an overwhelming number of studies. The topic should be interesting, and we got to get something out of this. There should be some specific knowledge to be gained from the analysis.
Traditional methods of research review focus on statistical significance testing, but this is highly dependent on the sample size. So instead, meta-analysis focuses on the direction and magnitude of the effects across studies. We don't really care if it's significant. We want to know how big of an effect there is to see how meaningful the results actually are.
In meta-analysis, each study is a case in the analysis. Single studies will have a single analysis giving a single effect size. A more complex study may yield several effect sizes. What the meta-analysis does is represent the magnitude and direction of those single studies. And you know what else is really cool about a meta-analysis? The sample sizes in those single studies don't matter because we're looking at them collectively.
After choosing the relevant question, you have to identify the types of studies to be included. The studies must have overlap within to be able to combine them. Criteria may include participant characteristics, date ranges, experimental design, and types of studies. The criteria should be pretty clearly stated.
Your search for relevant literature will need to be done right. Cast the net wide and filter down with manual readings of the abstracts. These days, researchers gather through a variety of sources: Google Scholar, other authors working in the research domain, conference programs, dissertations, review articles, and good old hand searching are some of the potential sources for data collection.
Okay, so let's get ready to read. It is important for the literature review to be exhaustive, which can be exhausting. The goal is to be thorough, but not to the point of being too broad. It's important to use appropriate search terms. Having too many irrelevant articles will lead to a lack of focus.
Now that we reviewed the literature, the effect size is the key component of meta-analysis. Studies that include more participants provide stronger estimates. However, meta-analyses are often a mixed bag of sample sizes. The included studies are weighted by certain criteria, and the total mean is calculated. The mean effect size represents the direction and magnitude of all eligible studies. Forest plots are a common way of displaying results, and you can create these plots through a number of available software programs.
So there are a couple precautions with this. When conducting meta-analysis, make sure that there are at least 2 reviewers, that you sift and sift again. First, pre-screen to decide which studies to review in full. Then, look again at those studies to decide which ones you want to include in your review. Don't collect outcome data at the same time as eligibility information, because if the study is excluded later on, you wasted your time getting that data. Also, look out for those duplicate publications.
An important limitation of meta-analysis is that its results can only be as good as the original data is valid. However, it also protects against overinterpreting differences from across studies, and it can handle a large number of studies. This would overwhelm traditional approaches to review. It also allows us to evaluate what attributes of a study are related to smaller versus larger effect sizes. It also allows us to better balance concerns about maximum effect size and maximum representativeness when designing studies.
All right, everyone. Hope you enjoyed this intro to meta-analysis. I know you're itching to find those 200 studies on your research topic.